Good morning, year 4. Today, guys, I just want to apologize for what happened yesterday. The video was, I had an error with the voice and I fixed it. I will be repeating what I have been saying in yesterday's video just for you guys to understand what the whole video was talking about. First, I would like to welcome you back from the vacation. I hope you had a lovely vacation and happy Ramadan for all of you. I missed you so much and I'm very thrilled that we're going to meet online, inshallah, on Wednesday. So today we're going to start a new lesson, or yesterday we already started a new lesson about magnets, and we will be talking about different kinds of magnets and how is magnets related to electricity. So let's start again. First, we all know that iron nails are one of the most famous magnetic materials that we deal with. But we're going to take a closer look inside the iron nails. The iron nails are like any other matter. They are consisting, or there consists of smaller particles inside them, and we will learn how those particles are arranged inside the iron nails without being exposed to any kind of force. So as I told you, matter is made up of particles, and iron nails are matter, and they are made up of small particles. When I look closely to the iron particles, they will look like this. They will be scattered, as you can see. They are not arranged in a specific manner. They are just scattered all over the area inside the iron nail. But once we bring a magnet near the iron nail, something very weird happens to the particles inside the iron nails. First, we all know that when I approach, or when I bring a magnet closer to the iron nail, it will stick to it. It will get attracted to the magnet, of course. What happens to the iron particles are is this is very weird, and this what happens due to the magnetic force that the magnet applies to the iron nail. Magnets, or magnetic field, or the word magnet is a type of force, a pulling force, like the forces that we've learned in the previous lessons. So this what happens when we get the iron nail closer to the magnet. The particles inside it starts to rearrange and line up, as you can see. So because of the magnet forces, the particles will be in straight lines, as you can see. So what are the types of magnets? We have several types of magnets. Of course, we have the rod magnet, and there is also the famous bar magnet. We will find it a lot in our labs. There is this type of magnet which looks like the type of shoe wear, or the type of footwear that you will find at the bottom of the horse's feet. So that's why they call it the shoe, or the horseshoe magnet, because it looks very much like the horseshoe. The other type is the ring magnet, and we will find the ring magnet along with another type of magnet that I'm going to show you right now. You will find it in bags sorry, in the bags that are closed by magnets. They use for those bags the ring magnet, and another type of magnet I'm going to show to you. But first I'm going to show you this type of magnet, which is called the wand, or the wand magnet. Yes, because it looks like the magician wand, and that's why they call it this way. And this is the second type that I was telling you about, along with the ring magnet, the disc magnet. You would find the disc magnet at the back of the refrigerator magnets, the kind of magnets that we stick to the refrigerator. You would find the disc magnet and the ring magnet in both this and the bags that closes by the magnet. So now let's make a small class work. I want you to name the type of each magnet, so we're going to do it together. The first one, we just said it and it's famous and we use it a lot in the lab. It's called the bar magnet, that's right. And the second one is related to a specific animal. I'm just giving you hints. So this is a horseshoe magnet, and this is the one that I told you, it looks like the magician stick. I'm not going to say the name. Yes, a wand magnet. And this is the type of magnet, you find it in the bags, the ring magnet. And the last one is actually talking about itself. It's called the rod magnet. So that was yesterday's lessons. Today we're going to start talking about how the different types of poles in a magnet react together. So any magnet has two poles. The one with the S is called the south pole, and the one with the N is called the north pole. So here's a question. If we have two magnets and they are facing each other, how would they react against each other? Will they attract each other, or will they repel? Repel means that they are pushing each other away. So the question says, what will happen when the ends of the two bar magnets are placed close together? There are two scenarios for this question. The first scenario is if we're going to bring two bar magnets close to each other, but different poles are facing each other. So I have this bar and this bar, and I'm going to approach the north pole of this bar magnet to the south pole of this bar magnet. So what would you think will happen? I think the arrows are talking about are saying the answer actually. Yes, they will get attracted to each other. They will attract each other. The second scenario is if we're going to approach, or we're going to bring close two bar magnets, but we're going to face the two similar poles. For example, in this bar magnet, I'm going to approach the south pole to the south pole of the other magnet. What would happen to them? And the arrows are speaking up. They will repel, and repel means they will start to push against each other. They are getting away from each other. So this means that different poles attract. So whenever I want to attract two magnets to each other, I'm going to face or put the different poles facing each other, while similar poles will repel. So this means that if I want two magnets to get apart or push away each other, I am going to put the similar poles facing each other. Now let's do this small classwork. The diagrams below show pairs of magnets. The arrow show the direction in which the magnets move when placed near each other. In the boxes on each magnet, write the symbol N or S to show the correct pole. So now I have two arrows in the first one, and the two arrows are showing that the magnets are getting attracted to each other. They are coming closer to each other, or they are sticking to each other. So this means that at the beginning, if this is the North Pole, then this is going to be the South Pole of the magnet. And if the two magnets are attracted to each other, so this means that this should be similar or different from this pole. Yes, it should be different. So this is going to be the North Pole, and as long as this is going to be the North Pole, this one is going to be the South Pole. I think it's very easy and it's very simple. Now let's look at the next one. The next one shows that the arrow is showing that the two magnets are repelling from each other, or moving apart from each other. So that will make, at the beginning, let's guess together this pole. If this is the South Pole, then this is going to be, of course, the North Pole. And if the two magnets are repelling from each other, then this pole should be similar or different from this one. Yes, it should be similar, and that will make this pole a North Pole. Very good. Now, if this is the North Pole, then this is going to be the South Pole. Now let's see the next one. The next one are two horseshoe magnets, and the arrows are showing that the two magnets are repelling from each other. So this means that the poles facing each other should be similar or different. They should be similar. Very good. So this is going to be the North Pole, just like this one, and this is going to be the South Pole, just like this one. Now this is another page of classwork. Let's do it together. It's going to be very easy. We have pictures here. We are going to look at them and read the questions. North end facing south end. As you can see, the north end is facing the south end. So the magnets will move apart. Apart means far away or repelling, or together. Together means closer to each other. So if they are different, they're supposed to be moving together. Very good. The opposite ends of the magnet will attract or repel each other. They are different, so this means that they are going to attract each other. Very good. The next one is north end facing north end. So there are two similar poles or ends are facing each other. The magnets moved apart or together. Again, apart means far away from each other. Together means closer to each other. So this, in this case, the similar, they move apart. Very good. The north ends of the magnets will attract or repel each other. They will repel each other. Very good. Next, south end facing south end. Again, similar ends or similar poles are facing each other. The magnets moved apart or together. So again, they're going to move apart from each other. The south ends of the magnets attract or repel each other. It's very the same as the previous one, so they're going to repel each other. The next one is north end above north end and south end above south end. So it's the same. The similar the similar poles or the similar ends are facing each other. The magnets pulled together or pushed apart. They are pushed apart. Very good. Like ends of the magnets, because both ends are alike, so like ends of the magnets attract or repel each other. Do you think they will repel or attract? They're similar. They will repel. Very good. Next is north end above south end and south end above north end. So different ends are facing each other. The magnets pulled together or pushed apart. They are pulled together. Very good. Opposite ends of the magnets will attract or repel. It will attract. Very good. This is going to be your homework, page 76. It's pretty much the same like what we did before. In the first question, you're supposed to be looking at the pairs of magnet, and then you have to circle if those magnets are going to repel or attract. The next question is, they're showing you how the bar magnet have two poles. The N is for north and the S is for south. And then they bring you some pairs of magnet, and they're asking you if they're going to repel or attract. So you have here the first pair, and you have to write here, are they going to attract or repel? This is the second pair, and you have to write here, are they going to repel or attract? And here the last one, and again you're going to write if they're going to repel or attract. This is it for today, guys. We're going to meet inshallah live on Wednesday. I'm very excited for this. We're going to continue talking about this lesson, and we're going to correct the homework together. Until then, I hope you're all doing good. Stay safe and see you soon inshallah. Bye bye.